Alright, let's take a look at question number 13. In this problem, we're going to learn how to read projectile motion equations. Question 13 reads, the height of a ball or seen tossed into the air can be modeled by the function h of x equals negative 4.9x squared plus 6x plus 5, where x is the time elapsed in seconds and h of x is the height in meters. The number 5 in the function represents, so we have four options here. To get us started, let's go ahead and specify what the projectile motion equation is, and then we can identify what the different components are. All right. So formula is as follows. Let's put it. Yeah. Okay. All right. So the formula. This formula is for your projectile motion. Projectile motion. Alright, so your projectile motion equation is h of x. Sometimes it's written in terms of t. The independent variable here is x, so we're going to use x. H of x equals negative 1/2 gt. Let's use x. I said I was going to use x. 1/2 gx squared plus v sub 0 x plus h sub 0. Alright, now what do the different variables here mean? Let's start with g. G basically represents acceleration due to gravity. Acceleration due to gravity. Any object that's within the gravitational pull of the Earth will accelerate towards the center of the Earth. Okay? It's downwards or towards the center of the Earth. That's why we have a negative sign. Now, how about the v sub 0? The v sub 0 basically means this initial or starting velocity. So v for velocity. Initial or starting velocity. And then we have h sub 0. H sub 0. This sub 0 basically means start, okay? H sub 0 represents your initial or starting height. How far was the projectile before it was tossed into the air or dropped towards the ground? Initial or starting height. And then x represents the time in the air. And then h of x represents the height. Height from the ground. Height from the ground at any time x. At any time x. Okay? Alright. So just by setting these two equations, placing them next to each other, and mapping variables to constants, we can easily determine what the number 5 is. Alright, so let's go ahead and write down the function first that's given in the problem. So h of x is negative 4.9x squared plus 6x plus 5. And then let's put the formula underneath and then see what the 5 stands for. Okay? So h of x, we're going to write down this formula that we just wrote here, is negative 1/2 gx squared plus v sub 0x plus h sub 0. Okay, let's go ahead and map it. So we can see that 4.9 is basically half of the acceleration. So 1/2 g is 4.9. We can see that 6 is your initial velocity. The coefficient of x is your initial or starting velocity. The coefficient of x squared is half of the acceleration due to gravity, and the constant is h sub 0. Alright, so we can clearly see that h sub 0 equals 5. And what is h sub 0? We specified it here. It's the initial height. Okay, So 5 represents the initial. Initial is the same thing as starting, okay? Initial or starting height of the ball. Height of the ball. And that is option number 1. Okay, so for number 1, that's h sub 0, the h sub 0 value. Now let's attack the other options, okay? They are important for you to know because on your Regents exam, you might be asked to find the other components. Alright, so for initial height, that's h sub 0. Now, what if you want to find the time at which the ball reaches the ground? When the ball reaches the ground, the height from the ground is going to be 0. So in that case, for number 2, you want to solve when h of x is equal to 0. You want to solve that equation, or you want to find the zeros using a graphing calculator of this equation right here. For option 3, the time at which the ball is at its highest point. In order to figure that out, you simply use the formula negative b over 2a. Okay, so that's it right there. And then the last one, to get the maximum height, all you just have to do here is for number 4, you evaluate the function at the maximum time. So h of negative b over 2a will help you find what the maximum height is. Alright, so that's how to find the other parts of this projectile motion equation problem.